Today we're going to look at some shortcuts for showing that triangles are congruent. He knows. So when we first defined congruent triangles, we said that you had to prove all three pairs of matching or corresponding angles congruent and all three pairs of corresponding sides congruent. That's 6 things. That's a lot to do in a proof. What we're going to learn today is some shortcuts for doing that, where you don't have to do all of those things. You only have to do half. You have to do a particular half. So the first thing we're going to learn is called the side-side-side congruence postulate. It says if we've got 3 sides in one triangle that are congruent to the 3 sides of the other triangle, then those 2 triangles have got to be congruent. In other words, if the sides are all congruent, the angles will take care of themselves. So here we have all 3 sides of this triangle congruent to the matching sides of this triangle. So triangle FAR is congruent to triangle OUT by side, side, side. And that's the way we'll abbreviate it, is just SSS, rather than having to write out side, side, side congruence postulate, which is a lot to write. Okay? So that's the first one. The second one is called the side angle side congruence postulate. Instead of all 3 sides, you've got 2 sides and a particular angle. If 2 sides and their included angle of one triangle are congruent to the corresponding parts of another triangle, then the triangles are congruent. Notice that it says that it has to be the included angle. Well, what does that mean? Well, it means it's the angle that's in between those 2 sides, or the angle that's made by those 2 sides. So if we look at this triangle, we've got AC marked congruent to OD, AT congruent to OG, and in between these 2 sides we have this angle. It's the angle made by those 2 sides. So that's the included angle. And then the same thing is true over here. So this angle right here is the included angle. Between segment AC and segment AT. That's called the included angle. So here triangle CAT is congruent to triangle DOG by SAS, side angle side. Again, we'll just use a 3-letter abbreviation rather than having to write out the whole thing. Take a look at this example. Is this side angle side?
No.
Why not? You had to know the why not was coming. Is angle B between the 2 marked sides in this triangle? No, it's the wrong angle. Likewise over here, it shouldn't be angle L, it should be angle F instead. So this is not side angle side, because it's not the included angle. It's got to be the angle in between the 2 sides. And then the last one we're going to learn today, there are 2 other ones that we're going to learn, but we're just learning these 3 today, is the angle side angle postulate. Here, instead of having 2 sides and the angle in between them, you've got 2 angles and the side in between them. And that's why we have the S in the middle, because the side is in between the 2 angles. So if you've got two angles and their included side, see how this side runs in between those two angles? And this side runs in between those two angles? If they're congruent to the corresponding parts of another triangle, then the triangles are congruent. So here I've got triangle GEO congruent to triangle MTR by angle, side, angle. So just those three for today: side, 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 angle, side, and angle, side, angle. Again, we'll learn the other two later. So one kind of problem that you'll do a lot of in this unit will be ones like this. Decide whether you can conclude that the triangles shown are congruent. If so, name the postulate that's being used and write a congruence statement. The congruence statement is where you say triangle ABC is congruent to triangle XYZ, whatever they happen to be. And you have to make sure that the corresponding parts match up. So let's take a look. For this first one, and this is going to happen a lot, there's not enough marked on the diagram. There's only one pair of congruent sides and one pair of congruent angles. But see how these two triangles are stuck together right here? We can say that this side is congruent to itself by the reflexive property. So now if I look at one triangle, so just look at the triangle on the left. How many sides are marked in some way? Two. And how many angles? One. And is this angle in between the two sides or not in between the two sides? It's in between. So this is side, angle, side. And our congruent statement would be something like this. Triangle ABD is congruent, and then I've got to make sure I match up the corresponding parts. So A in this triangle matches up with what in this triangle over here?
CBD.
Yeah, it's C, and then B goes with B, and D goes with D. For number two, we've only got one pair of angles marked congruent, but we know that all right angles are congruent, so we can add that to the diagram. These two right angles are congruent to each other. So now I've got two pairs of angles congruent, and I've got the sides that go in between those. So this is angle, side, angle. Two pairs of angles are marked, and one pair of sides that's in between them. So that's angle, side, angle. And for my congruent statement, I can name the first one any way I want. I'm going to call it triangle KLJ. Doesn't matter what you name the first one, you just have to make the second one's parts match up. K in this triangle matches with what in the second triangle? What is it? What does K match up with in this other triangle? T. And then L matches up with what in this triangle? N. So J must match up with M. For number three, we've got one pair of angles marked and one pair of sides marked. That's not enough. What is it in this diagram that we know are congruent all the time? That we've been using, since the second unit in the year? The vertical angles, exactly right. We know that these two vertical angles are congruent. So now in each triangle, I always start with whatever I have the most of. I've got two angles in one side in both triangles, and in both cases the side is in between the two angles. So that's angle, side, angle. Name the first one any way you like. I'm going to call it triangle LUP. Match up the corresponding parts. Angle L Look at the angle marking, matches up with T. U matches up with the angle U on the other side. And then it must be S that goes with P. For number 4, they've marked the top and the bottom are congruent, but what do these triangles mean? They're parallel, exactly right. And when we've got parallel lines, we should have some angles that are congruent. In this unit, it's almost always alternate interior angles. Every now and then it'll be corresponding. So I know that these top and bottom alternate interior angles are congruent. That's the alternate interior angles theorem. That's still not enough. It's only two pairs of things that are congruent, but see how these two triangles are stuck together on LV? This side is congruent to itself by the reflexive property. So now in each triangle, again, I always start with what I have more of. I've got two sides and one angle. And the angle is in between the two sides. So that's side, angle, side. If I name the first one EVL, E matches up with O, V in the bottom triangle matches up with L in the top triangle, and then L must match up with V. Before we go on, I'll point out to you that all of these worked. Sometimes you don't have enough information and you just have to put none. There is nothing that will prove those triangles congruent. All right, so let's fill in the parts on proofs. By the end of this unit, you'll be writing proofs on your own. So let's take a look at this one. We've got that AR bisects angle DRT, and that segment DR is congruent to segment TR. So I'll go ahead and mark the two congruent sides. For this one, I need to fill in the first given. How do I know that's true? Because it was given. Now, if we bisect angle DRT, and I need to fix this because this is not correct, so please fix that. It should be angle DRA is congruent to angle TRA. If we bisect angle DRT, that's down here at the bottom. So these two angles are going to be congruent to each other. I know that because it told me I had a bisector, so that's the definition of angle bisector. Then what is segment AR congruent to? It has a blank here. Yeah, it's congruent to itself. That's where they're stuck together. Anybody remember what that's called? Yeah, it's the reflexive property. Now we have enough to say that the two triangles are congruent. If I just look at one triangle, I've got two sides and an angle, and the angle is in between those two sides. So that's side, angle, side. All right. One more. This one's a bit more involved than the last one, and I've left things out on both sides. So we start with all this information. How did we get all of this information in statement number 1? It was given. And in the given, I have some perpendicular lines, and I've got something about a midpoint. So if the lines are perpendicular and it asks me about angle B and angle, and I apologize, I need to go back and fix this one. This should have been angle T. We know that angle B and angle T are, if these are perpendicular lines, what do they make? Right angles, exactly right. So these are right angles. And how do we know that?
Use the midpoint
Oh, no, it has nothing to do with the midpoint.
of.
Definition of something.
Oh, we know, perpendicular.
Yeah, we knew we had perpendicular lines, so we conclude right angles. Good. Definition of perpendicular lines. If those are both right angles, then I know that they're congruent to each other. Angle B is congruent to angle T. This is because all right angles are congruent. So far I know these two angles are congruent. Then it wants me to use the definition of a midpoint. Well, if W is the midpoint of BT, then what conclusion can we make?
Segment B is congruent to segment T.
Well, B is just a point. I don't think that's what you meant. You mean this whole segment, right? What's the name of that segment?
BW,
Yeah. Segment BW is congruent to WT. Very good. Segment BW is congruent to segment WT by the definition of a midpoint. And then it gives you a pretty big hint as to what to do next. Angle OWB, that's this angle, I'm going to mark it with 2 arcs, is congruent to, well, it's got to be this angle, because what kind of angles are those? Yeah, they're vertical angles. Angle IWT. Because vertical angles are congruent. Now we have enough to prove the 2 triangles congruent. We've got, if I look in one triangle, I've got 2 angles in one side. Is the side in between the 2 angles? So is this side between the 2 angles that are marked? Yeah. So that's angle, side, angle. There's a long hesitation there. It's okay. All right, I have a worksheet for you. You have a fair bit of time